Okay, well, this is just a quick video to cover testing Smoothtop electric range surface elements, like this one. So generally we're going to be seeing this from the underside if you haven't unmounted it, but it's interesting to see how they're constructed. The element portion of this element, you can see, is just a wire that comes out on these two terminals. So the simplest, bare minimum test, if you think the element itself is burned out, test resistance, check between these two tabs. Look at that. We've got 45 ohms. Okay, well, it's a good reading. I don't even need to check the spec. I know 20, 40, 80 ohms, those are all right in the realm of possibility for a heating element. It was dead steady. It varied a little in the tenths digit, but it's not jumping around. And for a heating element, more importantly, it's not millions of ohms. It's not mega ohms. It's about 50 ohms, 45 ohms. That's a good element. So, I guess that's all there is to say. Just kidding. So, you notice one of these terminals is spot welded to this device here. So, this is a safety device. It's effectively a high limit switch, or a cutout thermostat. Just like a dryer heating element circuit, this has an intrinsic safety built in to where the wiring harness connects to one of these tabs, right here. The other one, the harness would connect here, and this puts a cutout switch in series with the element. So this device is in two halves. We're going to talk about this half first, the left-hand half as I'm looking at it. So this rod that runs across the element, that expands with heat. And there's a switch contact in here that will open when that rod gets, say, over 800 or 1,000 degrees Fahrenheit. We'll lose continuity between these two tabs, between these two terminals. I don't have a very good connection right there, but you can see it's a closed circuit, right? And so, a better test, if we were only going to run one test and we wanted to validate the whole element, we want to know that the safety device is good, the element's good, everything's hunky-dory, we could test between these two tabs, and now we're measuring the resistance of the element commoned over to the high limit switch all together in one reading. And if the high limit switch was faulty and at ambient temperature, at room temperature, it wasn't closing, then we wouldn't get a good reading here. And if the element was burned out, if it had a burn spot, then we wouldn't get a good reading here. And that's a good troubleshooting strategy. Try to find one reading that'll tell you as much as possible, that'll rule out as many problems as possible. All right, so that is pretty much it. We can talk about these two terminals over here. These are the same device, but they have a whole different function. These are just a switch output to activate the cooktop is hot indicator. The same rod, if this gets over a much lower temperature, say 200 degrees Fahrenheit, these contacts close and they light up that indicator. And generally all of the elements of the cooktop will be common together, so that if any one of the elements indicators close, then the light would light up and say something on the cooktop is hot. Okay, one last parting thought on resistance checking. I have another little demo here. You'll notice I'm using resistance setting rather than the continuity setting, the beep setting. That's a good idea anytime you expect something to have resistance. The only difference between the resistance setting, and the continuity setting, continuity is just low resistance. So it's up to the manufacturer of the meter to define what low resistance is. Here, for example, I have a 75 ohm resistor. I'm going to test that in continuity. You see, my meter displays the resistance, but it doesn't beep, because 75 ohms is over the beep threshold for this meter. Now here's the trickier bit. Here is a 1K resistor, a 1000 ohm resistor. I measure that. My meter doesn't show anything. In a sense, my meter's lying to me, because if I go over to resistance, now it shows, yeah, that's 1000 ohms. But the same test, if I'm nimble enough, on continuity, it shows OL. Because 1000 ohms is over this meter's threshold to even display resistance in continuity mode. So continuity is great if you're looking for a break in a wire. You know, you want it to beep, and then you want to wiggle the wire, and you want to find where's the break? Or if you want to check switches, anything that's meant to have almost zero resistance. But anytime you're checking something that's meant to have non-zero resistance, that's really the reason this is a heating element is because it has resistance. No, use the resistance setting. You'll be better off. You'll thank me later. Thanks for watching.